All right, welcome. We're going to talk about some indeterminate forms today. There are certain types of limit problems that are kind of easy ones to figure out. Say the limit as x goes to 0 of x squared all over 5. Well, that's easy. That's 0 over 5. That's 0. So in general, sort of 0 over constants, they just are 0. But in something like the limit as x goes to 0 of 5 over x squared, well, we've seen this, right? The bottom is getting smaller and smaller and smaller, so 1 over it is getting larger and larger and larger, so the whole thing is exploding to infinity. So things like that are converging to some constant over trying to have a 0 in the denominator, they blow up to plus or minus infinity. And there's similar stories with infinities. If you had things like a constant and the bottom was trying to blow up to infinity, well, the bottom's getting bigger and bigger, so 1 over it's getting smaller and smaller, so the whole thing would go to 0. And if you had sort of the numerator trying to go to infinity and the bottom going to a constant, then the whole thing would just be carried along to infinity. Those are, you can just look at them and figure out. But things like the limit as x goes to 0 of sine x all over x, well here the top is trying to go to 0 and the bottom is trying to go to 0. And we just don't have any theorems that can handle that. And the truth is, the reason is that these are just hard. They're always much harder. And it'll turn out later, we'll see that it's because it really is a matter of how fast they're going to 0 and who's going to 0 faster. And the answer could be anything from not existing to infinity to 5. It just could be anything. It's very subtle. So things like this, when the limits are trying to converge to 0 over 0, so to speak, on the top, or infinity over infinity, these are called indeterminate forms. And in fact, it just means it's something that's hard. You can't just eyeball it. There are other ones as well. There are things like infinity minus infinities, 0 to the 0. What else is on the list? 0 times infinity, 1 to an infinity, infinity to the 0. All of these, just when the limits of each part is trying to go to something of this form, then they're just hard. We're going to look at a couple cases where we actually can figure out the answer in this section. So we'll do that by example. The real truth is that there's no one technique that always works for these. It's just a hodgepodge. And some of the common things are like simplifying, factoring, common denominators, multiplying by the algebraic conjugates. Those are tricks that in many scenarios can give you the answer. So here we go. Let's do the limit as x goes to 3 of x squared minus 4x plus 3 all over x squared plus x minus 12. Now that x squared there, well, if you plug in, you'll see this is both of them are converging to 0, which is why I can't use the ideas from before just to plug in and get the answer. So the trick in this case is to actually simplify. And that's because there's some factoring going on. So the first one factors as an x minus 3 times an x minus 1, and then the bottom would be an x plus 4 times x minus 3, which is awesome. We can cancel those and get the limit as x goes to 3 of x minus 1 over x plus 4. Now, there isn't any 0 over 0 here because when I can just plug in and get the answer because it's continuous. So I get 3 minus 1 over 3 plus 4, so I get 2/7. All right? So sometimes factoring will get rid of these indeterminate forms. Here's another example. The limit as x goes to 9 of x minus 9 all over the square root of x minus 3. Again, this is sort of this, the top is trying to go to 0, the bottom's trying to go to 0, so I can't just plug in and get the answer. So the trick here is this multiplication by algebraic conjugates. So multiply the top and the bottom by the square root of x plus 3. And then the bottom will be x squared minus 9. So that's good news. Looks like we got some canceling going on. And by x squared plus 9, I mean x minus 9. So it's the limit as x goes to 9 of the square root of x plus 3. Again, this is just continuous. You can plug in square root of 9 plus 3. So 6. All right. Let's do another example here. So the limit as x goes to 1 of x cubed minus 1 all over x minus 1 cubed. Again, this is looking like 0 over 0. The top is trying to be 0, the bottom is trying to be 0. You can't plug in 0 in the denominator, so we're going to try some factoring, and it does factor. So the top factors as x minus 1 times x squared plus x plus 1. And we get an x minus 1 cubed in the bottom, so we can factor some of that. So we get the limit as x goes to 1 of x squared plus x plus 1 all over x minus 1 squared. Now the bottom is trying to go to 0. The top is trying to go to 3. So it's going closer and closer to something like 3 over a very small number. And as the denominator gets smaller and smaller and smaller, it blows up. Okay, so this actually is infinity. Finally, I'll just give you one hint for things like on the homework. If you had something like this going on, and you were trying to let x converge to 1 here, you would see it look like 1 over infinity minus 1 over something trying to be infinity, and who knows what that is. The trick on that one is if you just did common denominators, and then do the tricks we had, you'll get some canceling and the answer will pop out. All right, that's it for some indeterminate forms. Ciao.